Well, we'll go ahead and kick things off a little bit early. So, hello, everyone. Welcome to the HamptonRoads.net users group. Uh, my name is Kevin Griffin. I am joined by my cohort, Drew. How are you today, Drew?
Doing well, and you, sir?
I'm doing very well for a Tuesday. uh, we are pleased to have our special guest tonight, Dan Moore. Dan is going to talk to us about what OAuth, right? So OAuth and protecting our APIs. And I know we have a lot of folks out there interested in that topic of all different levels. Um, so Dan, I think we're just going to turn it over to you and let you get started talking. Um, so that everyone watching live, which I see the number going up, so that's usually a good sign. If you have any questions at all, feel free to drop them in the chat. Myself or Drew will chime in and answer them the best we can, or pitch them off to Dan so he can answer them the best he can.
Sounds
But
great.
Dan,
And
you want to go ahead and get your screen shared, and we'll get this kicked off.
to answer the first question, no, this is a dog bed, and they're currently outside.
Dog.
All
All
right.
right, Dan, I see your screen.
Perfect.
All right, Dan, you are all set. Go ahead and take it over.
Okay, great. So thank you very much for having me. I'm going to be, as Kevin mentioned, I'm going to be talking about protecting your APIs with OAuth. And I will say that this is probably less .NET heavy than your typical presentation. I definitely can speak to some of the aspects of .NET, but the nice thing about OAuth is that it works across different environments. So it's really a great solution if you need to protect APIs, and some APIs are written in .NET and some APIs are written in Go, and God forbid some APIs are written in PHP. Just kidding. I love PHP. But it's a really good kind of solution for a heterogeneous environment. So, and let's get on with the show. So, real quick about FusionAuth, because I am head of DevRel at FusionAuth, and it is an auth provider. So you can think of it as similar to core identity within the ASP.NET framework, except for just like you abstract a database server sometimes, you also can get benefits from abstracting an authorization and authentication server. So FusionAuth is that. We're not the only game in town. There are other ones. A .NET oriented one is called Identity Server, or I think they rebranded it under the name Duende. There are other ones out there like Auth0 you might have heard of, but FusionAuth is a dev-centric one, and we basically let you focus on building your application, and we take care of authentication, authorization, login, forgot password, some user management pieces. It's also useful to protect APIs because FusionAuth generates tokens, and those tokens, as we'll see in this presentation, can be used to protect arbitrary kind of APIs that you might write. So you would outsource the authentication to FusionAuth. FusionAuth gives a client, whether that's a browser, a native app, or something else, a token. That token is then presented to your APIs, and your APIs can examine that token and see what who holds that token and what they should have access to, and then can give access to functionality or data based on that token. And again, I'm going to use FusionAuth throughout these examples, but the principles hold true across other identity servers as well. Real quick about me, who cares? You didn't come here to learn about me. You came here to learn about OAuth and tokens and all that good stuff. If you have questions, we have 10 or 20 minutes at the end of the talk, but feel free to, as the host mentioned, ask the question in the middle. I know there's going to be some bit of lag, so I'm happy to go back and forth between slides. That's pretty easy for me to do. So let's talk about what we're actually going to cover today. We're going to start off and talk about OAuth and kind of the problems it solves and some of the major players and the names that they're given. We'll talk about how you can get tokens and actually what a token even is. and the various kinds of tokens that are involved in OAuth and OIDC flows. And then we'll talk about what you need to do as a client of a token. So that's someone who gets a token from an identity server such as FusionAuth, what you need to do to take care of that token. And then we'll talk about it as a consumer. And so that would be your API, right? An API gets a token from a client and then allows or disallows access based on that token. So how does the consumer know what to check even? I always like to ground these kind of presentations in a little bit of reality, and not too much reality, but a little bit of reality. So let's talk about a to application, right? This is a normal notebook where you write down things that you might want to do, and then you have a little checkbox, and you can either check it off or move it to the next page if you didn't get it done today. We're going to turn that into a web application at an abstract level. So here is our over-engineered to-do application. We have our clients over here that are probably running, a React app or some kind of single-page application on the web browser. On the mobile app, it might be, Electron app or something else, or it might be a native app. We don't really care what the actual technology is. Then we have our OAuth and user management platform, which backs up to a database of users. And so that's going to have user information in it. And then we have our to-do API. And that API talks to a data store of to-dos. And so this immediately is different than your typical monolithic application because you end up having, at least two endpoints that your clients need to know how to interact with. And in a real world application, something that's not just kind of a straw man for a meetup presentation, you're probably going to have more than one API, right? You'll have kind of one OAuth and user management platform, but you might have a to-do API, you might have an email API, you might have a reminders API, you might have a sharing API. There's lots of other kinds of APIs, and that's one of the strengths of OAuth is that you still have one source of identity up here in the OAuth and user management platform, but you can layer in APIs as you need to. So again, we have our client, and again, this could be any kind of client that can speak HTTP and can accept redirects. We have our OAuth server, and I'm going to refer to it as an OAuth server because that's kind of how I think about it. But if you're reading the specifications, good old RFC 6749 and 6750, you're going to want to know that it's actually called an authorization server in the OAuth world. And then we have our to-do API. And again, I refer to it as the consumer because from the standpoint of the system that I'm thinking about, it's consuming the tokens and giving back data or functionality. But in the specifications, it's called a resource server or an RS. So the OAuth and user management platform is where the user authenticates. The client is who they authenticate to, is the piece of software that wants access to the data. And then the resource server is the thing that holds the data or functionality. So let's take a step back and talk about what problem does OAuth solve? Like, why would you care about using OAuth? If you've been around for a while, you might know OAuth 2 was specified in like 2012, and it was really to solve the problem of I want to give some random application access to my Google contacts or my Google Calendar or my Facebook friends without giving them my username and password. And a lot of people think that's what OAuth is used for nowadays. But what it really solves is secure delegated access. So that lets me allow anything to have access to some set of data as me without giving it kind of the keys of the kingdom, which is what it would have if I gave it my username and password. And more we see this where it's actually not happening across organizations. Like the example I gave about the origins of OAuth 2, it's happening even within organizations. So what we want to do is we want to let this client, right, whether that's a web browser or a native app, have access to this data in the To-Do API, but have all the control mediated by this identity server, this OAuth and user management platform, so that um, if the user wants to, if the user's permissions change, if the user's access changes, if the user uh, gets their account locked, we have all of that information in one place. Another good thing about using an OAuth and user management platform like this is that you can actually have this system increase its assurances about the user, or offer different alternative login methods. And those could be things like requiring multiple forms of authentication, right? An SMS message, or using time-based one-time passwords, or WebAuthn, or something else. And as long as it still generates the same kind of token, the To-Do API doesn't care. So you can actually have this, as time passes and as your business needs change, have different authentication requirements without ever modifying the APIs or any other applications that hang off of that management platform. So again, the client wants to get access to the To-Do API without ever actually having access to the username and password that it might have to do if we were talking about kind of an older school system. So let's talk about how to get a token. Or actually, I should pause. Any questions about OAuth and kind of the main players in OAuth?
There is no questions right now.
Thank you, Drew. All right, so let's talk about how to get a token. And this is through OAuth has these things called grants, which are basically just like flows of users, or sorry, not flows, flows of data through the authorization server and the resource server. There's a couple of different kinds of grants. As far as I know, there's maybe 10 or so that have been specified. The two that are really important are the authorization code grant, which is the grant that you use when a user is involved. And then there's the client credentials grant, which is better for service to service communication. And you can use this when you have basically something where there's no user involved, no users logging in. Example of this might be if we had this to-do app and we had a reminder service that just ran once a night, and it looked at all of my to-dos that have like a date tied to them, and was prepared to send out a reminder to every user who had to-dos that were due in the next 24 hours. That's a service that's running, right? It's a cron job or a scheduled service, and so there's no user involved. So this is where a client credentials grant would make sense. But we're going to really focus on the authorization code grant today. I just wanted to give you kind of a taster of the other grants that are out there. So with the authorization code grant, we have a situation where, again, we have our client here. In this case, it's just a native app, but again, this could be a web browser or something else. And we are going to talk about two distinctions that make a lot of sense here. The first is this distinction between server side, which is on your right, and client side, which is on your left. And with clients, whether they're web browsers or native apps or desktop apps, you really can't trust the clients to do much of anything. You don't know what code is running on them. You have a harder time deploying updates. So we end up doing a lot of things on the server side to kind of counteract the untrustworthiness of client side things. But on the server side, it's your code or code that your open source packages you've installed that you hopefully you've trusted, and you can control secrets, you can rotate things, you can deploy things pretty easily. The other distinction is, where do credentials live? And by credentials here, I typically mean username and password. There could be other kinds of credentials, but a lot of OAuth systems kind of expect username and password to be involved. We can talk about some of the other ways that a user can authenticate if you all want. But if you're thinking about username and password, like those are very precious uh, bits of data. Have I Been Pwned, which is a website out there, I think it's got like over like 11 billion username and password combinations that have been compromised. And this guy, Troy Hunt, runs a great service, which basically will let you type in your username and it'll tell you whether your password's been compromised or have been found to be compromised. And so the point of that is that you want to protect these credentials. And so what OAuth lets you do, OAuth and some of the affiliated um, specifications, what they let you do is they let you isolate the credentials. And who has access to a username and password? Well, the client does almost by definition, unfortunately, because that's where you have to enter the information. But even within that, there are ways to lock down what aspects of the client have access to those credentials. And then on the server side, the OAuth and user management platform does, because it has to like receive those credentials and verify them. And obviously there's some credentials stored in the user's database, but the other pieces of the application don't have anything to do with credentials, or at least not the username and password. They do get that token, and we'll talk a lot more about the token in a little while, but they get a token, but that token is time bound. That token has no long-term value, and um, so therefore it's a safer thing to pass around. So let's kind of walk through the authorization code grant in excruciating detail. So what you do is the client sends a request to the OAuth and user management platform, and then which sends back some HTML, and then that basically lets the user behind the client enter their username and password. They post that to an endpoint, which then causes the OAuth and user management platform to verify the credentials and do anything else, right? Like, again, this is a strength of OAuth, is that up here, when you're posting a username and password, there may be other steps you have to take to verify yourself as a user. I mentioned MFA. It could be that the OAuth and user management platform is smart enough to say, hey, this user logged in Boulder, Colorado, which is where I'm from, and 2 minutes later they logged in from Germany. Wait a second, something's going wrong here, and take actions based on that, right? They could lock the account, they could send a user a message, they could inform an administrator, they could do other things. But that's all tied into the OAuth News Management platform. The downstream applications don't care what happens there. They just care about the token. So after the OAuth News Management platform has authenticated the user to its satisfaction, whatever that level is, it sends a 302 redirect with a authorization code, and that's a one-time code, and it's just basically a long string of letters. It's not anything that means anything to anybody, right? So the important thing here is it's one-time use. So that means if someone steals it after the fact, it's not going to be useful, and it is high entropy, so it's going to be hard for people to guess. So then we pass that code in to what we call the application backend. And this is something that is taken care of by a lot of libraries within the Microsoft ecosystem. There's an OpenID Connect extension that you can add. And I'll just show you some code real quick. This is just a sample application we wrote. And basically, you're adding the OpenID Connect extension, and you specify a couple of things, and we're going to come back and revisit this code again, but the point is that you typically are not going to have to write this application backend. That is typically going to be a library you're learning how to configure, but you're not necessarily going to have to write. in addition to providing that one-time code, you also have configured client secret. And that basically is something that's been previously set up in the OAuth and user management platform that uniquely identifies this particular application. So the combination of the code, which is tied to the user, and the secret, which is tied to your application, basically are provided to the OAuth and user management platform to an endpoint, and there's a couple other things that are passed to it, and then it returns those tokens that I've talked so much about. And again, there's a couple of different kinds of tokens, ID, access, and refresh, and we'll talk about all of those in a little bit. Then the application backend sends the tokens down, an access token, a refresh token. The access token is often a JOT, a JSON Web Token, which is why that's marked as a JOT. And finally, we get to presenting our tokens to the To-Do API. And at that point, we've gone through all of this rigmarole, and we actually know, because of the tokens, the To-Do API can know who is making this request and therefore can give the correct data to that user. Because you can imagine that someone who's an admin in the To-Do application might have access to different functionality than someone who's just a normal user. Then the To-Do API hands back the to-dos as JSON, and you are off to the races. And honestly, this right here, this request back and forth to the To-Do API happens a lot more often than everything else I showed you. That's going to be the majority of kind of the network traffic if you count by numbers. And that's one of the benefits of using OAuth, is that you have this kind of, again, delegated authentication. So there you have your To-Do API and the authorization code grant. So let's talk about who's responsible for what pieces in this OAuth flow. So again, we have our client, the various components of our application, and our databases. So the OAuth provider is responsible for this OAuth and user management platform. As I mentioned, FusionAuth is one, but Azure AD is a big one. Actually, I should have mentioned that kind of way at the beginning. Identity server, Keycloak, Auth0, et cetera, Like there's a number of these out here, but that's going to be all code that you interact with via basically a standard set of requests. The To-Do API is the responsibility of the app developer or the team of app developers, and obviously the client is as well. And then I already mentioned that the app backend typically is going to be taken care of by a library. It doesn't have to be. You could actually code it out yourself. It's a couple of lines of like posting form parameters, but it's better if you can kind of leverage an existing what's the word I'm looking for? An existing like open source library, or even a closed source library. So let's talk about these tokens a little bit more. So I've been being a little bit sloppy in my description. OAuth is a protocol for authorization, and there's no identity necessarily embedded in the output of an OAuth flow. There's a layer on top of it, which is very commonly used with OAuth, which is called OpenID Connect, which leverages the same flow, the authorization code grant, and includes identity information. So for OAuth, there's something called the access token, and there's a refresh token. And then for OIDC or OpenID Connect, there's something called the ID token. So let's look at each of these. Per the specification, access tokens are opaque. What do I mean by opaque? It means that it's not supposed to mean anything to anybody who holds it as a client, right? You aren't supposed to be able to look inside the token and see anything. It's not guaranteed. And different identity providers have different formats for their access tokens. it does mean something to the resource server or the consumer, and we'll see kind of how that looks in a little bit, but the actual client shouldn't look at an access token. However, a lot of identity servers do use a format called JSON Web Tokens, or it's in the specification, it's pronounced JOTS. And JSON Web Tokens have like intrinsic structure. So they're a JSON object that is turned into a URL encoded string and can be passed around safely in form parameters or in HTTP headers. But but you can't know that, right? If you're purely following the specification, you can know that by looking at your OAuth and user management servers documentation. But if you want to be strict about it, don't expect to look at the access token. The other thing to be aware of is that access tokens are for the consumer, right? So they're generated by the OAuth and user management platform, but the to-do API is really the main thing that should be accepting them and examining them and controlling access based on them. Refresh tokens are, again, they're opaque. And what they do is they let you, as a client, get new access tokens. And the reason why you might want to do this is because you might want an easy way to relog in a user without forcing them to re-authenticate. And again, we'll talk more about the refresh token grant in a little while. And refresh tokens are presented to the OAuth server. So again, they're held by the client, and then they're presented to the OAuth user management platform. And then that will actually, if it's a valid refresh token, provide a new access token in exchange. Finally, there's ID tokens. And as I mentioned, they're not strictly part of OAuth, although they're very, very commonly paired. They are part of OpenID Connect, which is a layer on top of OAuth. And they are, by the specification, they are JSON Web Tokens. ID tokens don't contain authorization information, or they shouldn't. They contain authentication information and identity information about the end user, and who they're really supposed to be used by is the client. So a canonical use case is you might hand out an ID token that has the user's name or their email address so that the client can display the username or the email address or their first name, last name. Any questions about the authorization code grant or tokens?
There's no questions at this time.
Okay, great, thanks. So let's talk about bearer tokens. So the idea is that the access token that you're given gives you access to the to-do API, right? And so you can think about an access token as being very similar to a car key. If I hand my car key to Drew and he's next to my car, he can get into my car. My car doesn't care who is holding the key. Or if somebody finds my car key on the ground, they can pick it up and get into my car as long as they know which car the key is corresponding to. That's because holding the car key is what gives you access. So the same thing is true by and large with access tokens. Holding the access token allows you to get access to the data that it is the key to, essentially. So that means if you have a bad actor, somebody that malware running on a mobile device, or somebody bad JavaScript that gets access to an access token and then sends it off to another server, and that server then can call an API presenting that access token. Those interlopers, those illicit holders of the access token, can't be distinguished from a legitimate access token bearer. They all get the JOT gets shown to the to-do API and is going to happily hand back to-dos for based on who it thinks is holding that access token, but it's not tied to the user who went through the authorization code grant, for example. There are some specifications out there that let you tie things a little more tightly between the client and the access token, but they're not widely implemented. And I have not actually seen them in the wild at all. I am happy to talk about those, my understanding of those, or give you some names of those specifications if you're interested in learning more about the way to kind of circumvent this attack, right? Of someone grabbing an access token and then, basically presenting themselves as somebody who they're not. Feel free to ask a question about that. So, given the context around bearer tokens and how precious they are, right? Just like I'm going to be careful with my house key or my car key, because again, the key doesn't care who holds it as long as it always grants access to my house or my car if someone has it. I'm going to be careful with the access token as well. As a client, you need to be careful with that. So, um, again, the client has to have access to it because that's what it's presenting to the to-do API. And a token is way less dangerous than a username and password, but you still need to be careful with it. So as you pass tokens around, hopefully this doesn't need to be said in 2023, but I'll still say it. You should only interact with production data over HTTPS. You want to make sure that the token doesn't get cached, right, at any intermediate step. And you as a developer don't have any idea where the client is coming from. They could be behind a corporate firewall. They could be over a mobile network with intermediate caches in between. Their ISP, if they're doing it from home, their ISP is going to be examining conceivably some traffic or at least logs. So you want to make sure that you don't put it in a URL in any way, and that you don't stick it in any query strings unless you really don't care what the access token controls access to. So where places you can put it, form parameters are great, headers are great, cookies are pretty good. Those are places that are transmitted safely and not cached. Now, as far as kind of where you're storing them on the client, right? So that the previous was like in transit security. Now let's talk about, at rest security. So the right place to store a token on a client depends on what kind of client you have. So for a mobile application, you want to think about storing it in something that's isolated to the application and preferably encrypted. Unfortunately, it can't be a kind of a one-way encryption, because you need to, after you get the token, you need to pull it out to present it to the resource servers. But for iOS, you can put it into encrypted storage or a keychain. Android has encrypted storage, or app preferences are isolated to a given application. So basically, wherever you would store something precious that you want to secure is where you'd want to where you want to put the access token. And a lot of auth libraries will do this for you. If there's OIDC compliant libraries in your native app, then they might take care of storing this token securely. As far as browsers go, you have some options. Cookies are what we typically recommend at FusionAuth. And the way that works is that the app backend, which you remember, does that token exchange after it has the code and the client secret. It gets those tokens back from the OAuth system and can send those tokens down as an HTTP only secure cookie. And let's just say the app backend is running on example.com. It can send those down as an HTTP only secure cookie for the entire example.com domain. And then if the to-do API lives on todo.example.com, it will get those cookies automatically. And then it can pull the access token off of the cookie and do the examination and the checks to make sure it's a valid token. And then therefore, after it does that, hand back the to-dos as JSON. So the nice thing about a cookie option is it's really transparent. It's very easy for a developer because as long as you set the cookie correctly at the application backend and all your APIs live on a common domain, it runs just fine, right? The nice thing about setting it as a HTTP only secure cookie is that you remove an entire class of threat vectors, which is basically rogue JavaScript running in your browser. Cookies get locked down pretty tightly, which is great because you can leverage that security model. Where it falls down, of course, is if the to-do API and the application backend don't live on the same domain, and we'll talk about that in a little bit. Other options for storing things in the browser, you can store it in memory alone. And so in that case, you'd send down a response and it would be JavaScript or something like that. And then you just store it in JavaScript memory. And as far as I know, it's pretty unlikely for kind of a rogue script to be able to rummage around in a running process's JavaScript object set. But the downside of storing it in memory is if the user reloads the page, they have to relogging in again because you've lost the access token. Another option is to use a web worker. And this is something that I don't have a lot of experience with, but I've definitely seen solutions out there. Typically, they're wrapped in like SDKs, and the web worker is kind of the boundary. Another pattern that we see pretty commonly is called the BFF pattern. And no, it's not two best friends discovering themselves on a trip to New York City. But they're not best friends forever. It stands for the back end for front end pattern. And what this is instead of the application backend sending the tokens down to the client, the application backend holds the tokens and just attaches them to a session object. And then that session is what ties the client to the application backend. So then when the user wants to get the to-dos, they actually request it from the application backend, and the application backend looks up the tokens from the session and then makes a call out to the to-do API or any other APIs. And then it relays that. So it's basically like a little proxy. And, obviously a downside of this is now you're routing all your traffic through the application backend. If you have 10 different APIs, you have to scale the application backend and it becomes kind of a single point of failure. The positive is that now your tokens are always secure, right? Because they're on the server side and there's no domain limitations. So if you have the to-do API, which lives on example1.com, and a reminder API, which lives on example2.com, and a email API, which lives on example3.com, the cookie solution I talked about earlier just won't work. So you end up with this kind of lightweight proxy. It doesn't have to do a ton of business logic, although it can, right? It can start to look at the requests that come through and see whether it sees anything suspicious, but it doesn't have to. It can just be a simple lightweight proxy. So let's talk about token lifetimes. Actually, I should pause and ask Drew if there are any questions.
There are currently no questions. It's been a quiet night today.
Okay, no worries. Thanks. All right. So as far as token lifetimes, you want your access tokens to be short-lived. And again, it's because they are essentially credentials into your to-do API. So we typically recommend minutes or seconds. I've seen these be as short as like 1 second, which basically makes them kind of a one-time use access token. Refresh tokens, on the other hand, you tend to want to be longer lived. So days or months. And the reason why it's more useful to have them be long lived is that if you don't have refresh tokens, actually, let me take a step back. The reason why it's good for them to be long lived is because, again, it lets your user get another access token without requiring them to log in again. But because they're presented to the OAuth server, if you need to revoke access for whatever reason, right? Like the user hasn't paid their bill, or they've logged out, or for some other reason, when you present a refresh token to the OAuth and user management server, and the user's session is ended or whatever has happened that causes access to be revoked, then that refresh token grant will fail. and you won't get a new access token. So it's safer for it to be longer lived. If you imagine a world without refresh tokens, you have two pretty unsavory choices. The first is you can make your access tokens short-lived, and every time, for a minute or two, and every time that someone's access token fails, then they have to re-authenticate, right? They have to go through that whole authorization code grant again and re-enter their user and password. Well, I don't know about you, but that would bum me out. If you said, well, we actually want to build a token-based system and we're okay with the access tokens being long-lived, then you have to worry about the security risk. Because if someone steals an access token, it might be good for 30 days and they can pull down all the data and as far as the standards go, there wouldn't be any real way to notice that. Obviously, there are things the resource server could do or the other piece of the system could do to kind of monitor that, but you typically are not going to want to have long-lived access tokens. If you have long-lived access tokens, you're basically going to have a bad time. So I talked a little bit about the refresh token and what it's good for earlier, but let's kind of dig into the refresh token grant, which is really kind of a critical part of the OAuth grant or the set of OAuth grants. So here we have our client. And again, we've already kind of gone through the authorization code grant. So we have our refresh token and our access token, and we're just going back and forth, getting our to-dos. Maybe we're updating them, etc. Eventually, because access tokens are time-bound, there'll come a time when the to-do API says, actually, no, I cannot fulfill that request. Your token is invalid. It has expired. And so in this case, the client can actually catch that error and say, oh gosh, I was expecting a 200, but I got a 400. So I'm going to have to deal with this error somehow. Well, one thing I can do is see that I have a refresh token, and then I can present that refresh token up to the OAuth system, and maybe I'll get a new access token. And the OAuth system looks at that refresh token and says, oh, is this tied to a real user? Is this tied to a real session? Has the user paid their bills, etc.? Whatever checks it needs to do, and then returns a new access token, right? JOT2 down here. And then JOT2 can be stored and then presented as the to-do API. And now you get another 5 minutes of, or whatever the lifetime of the access token is, of access to the to-do API. And again, it's totally transparent to the user, right? Maybe this request takes a little bit longer than the normal request, but it's the speed of computers, so it's probably not going to be noticeable. So as far as kind of refresh tokens, your client needs to store the refresh token safely, needs to catch that access denied. And then sometimes catching that access denied is handled by an SDK. Sometimes it's not. And then if the access denied happens, you need to present the refresh token to the OAuth server and store that new access token safely. There's some specifications which try to increase the security of the refresh token grant by having each refresh token be single use. In that case, you're going to want to store not just the new access token, but also the new refresh token. The important thing to know here is that there's nothing the resource server or the consumer has to do. It just validates the tokens as it normally would, and it gets an old token and it rejects it, and then it gets a new token and gives access to the to-do JSON. So the past section has all been about the client, right? It's been about how the client gets the token, what it needs to do when it has the token, how to store it safely, how to refresh the token. Let's talk now about the consumer or the resource server. So as I mentioned earlier, it's called a resource server or an RS, and its job is really to accept the access token and then validate it. And we'll talk more about what validation means in a little bit. And then return the data if the access token is valid, or to return a known error code if it's not. So again, this is the to-do API in our simple application. So let's talk about validating tokens. There's two kind of main paths to do this. The first is if the access token has internal structure, and you know that because you've read the documentation of the OAuth and user management server, sometimes the resource server can actually examine it internally and not have to make any external network calls. The other option is what's called introspection, and that's actually where the resource server presents it to the authorization server, to the OAuth and user management server, and says, hey, I have an access token. Is this a good access token? So let's dig into each of these options. If you know that your access token has internal structure, and again, per the specification, you shouldn't. You don't know that. But in reality, a lot of the various servers will return an access token as a JSON web token, as a JOT, or an alternative format. There's one called Pasetto. And these are basically signed bits of JSON. So they have internal structure because they're JSON, and then they have some a signature, a cryptographic signature, so you can know who they were signed by. And with those two pieces of information, you actually can get everything you need as a resource server without actually talking to the OAuth and user management server. And so that lets you basically decrease the coupling between these two systems. If you're going to examine a token with internal structure, the first thing you want to do is validate the signature, and then you want to validate the claims. So here's a JSON web token in all its glory. There's three components to a signed JSON web token. There's the first in the green, which is called the header or the metadata. Then there's the payload, which is in blue. And then there's a signature, which is in gray. The header and the payload are both just URL base64 encoded JSON. The header has information about the algorithm that was used to sign the JOT, the type of JOT. The body or the payload is where things get interesting. And so this is where you have what are called claims. And that's just kind of drives me nuts. It's just fancy for the keys of the JSON object. The important thing to note here is that you can have not just primitive values, right? Not just strings or numbers or Booleans, but you can have complex objects. So the roles array could have another object or an object of objects nested within it, and that would be totally legitimate. If you can represent it in JSON, you can represent it in a JOT. So basically, in order to verify the integrity of the JOT, you take the header and the payload, and you concatenate them together, and then you run an algorithm over them, and you end up with a signature. And so that signature is tied to the contents of the body and the header, as well as the key that was used to sign it. As far as the body, you can't tweak the body of a JSON web token without that signature check failing. So if I were to change my role, because again, let's go back here real quick. I can see as a client, and remember, clients are malicious, or some clients are malicious. As a client, I can see the value of this JSON web token. So I could URL decode this, which makes it look like this. And then I could modify the superadmin or modify admin to superadmin. And then I could re-URL encode it and stick it back together with the header and stick it back to the signature and pass it around, right, to try to escalate my privileges. But if I do that, I'm actually going to, the signature check will fail because the signature is tied to the payload as it was originally there when it was first signed. So to validate the signature, it's a critical step, but typically you're going to use a library to do so. But let me take a step back here. There's two ways to sign it, two big categories to sign it. You can sign it with a symmetric key, which is something that I see in a lot of example apps, but it's not really useful in, it's only useful in certain real world situations. It's much more likely that you'll use it in a public, you'll sign it with a private key at the OAuth system, and then you'll verify it with a public key in the to-do API in the resource server. So how do you get that public key? Well, you can get it from a deployment time artifact, right? So we could create a public private key pair and store the private key in the OAuth system and store the corresponding public key in the to-do API. Makes total sense. And then the to-do API just, it looks at the JSON Web Token and it finds the identifier typically in the metadata in the header, and it says, oh, this corresponds to public key 123. I'm going to look up public key 123 from my file system, and I'm going to use that to validate that this JOT was not tampered with. The nice thing about this is that the to-do API and the OAuth system can be totally disjoint. They don't have to be on the same network. There can be no communication between the systems. That can have some nice aspects. Something that is a little more common, at least in the systems that I see, is the to-do API actually calls out to retrieve public keys that are hosted on a well-known endpoint by the OAuth system. And this is called the JWKS standard. And, because they're public keys, who cares who can see them? No one does. This is what the JWKS endpoint looks like, or just as a portion of it. Kind of busy. So let's zoom in on the parts that are important. For each public key, we have an algorithm that was used to create it. We have a key identifier, and we have the public key. And that's the X5C value. This actually could be a public key chain. So you could have a chain of public keys. In this case, it's just one public key. And the important thing to know is that key identifier, KID, starts with UK0, actually matches the key identifier that is passed in to the JSON Web Token. Now, this is, there are other ways to identify a public key. I'm just talking about the way that we do it at FusionAuth and the way that I've seen it commonly done. There are other ways to do that, but matching up that key identifier makes it really kind of foolproof that you can know which public key corresponds to the private key that was used to sign this JSON Web Token. Because of some of the complexities there, it's really suggested to use a library. And again, Microsoft offers the OpenID Connect extension, which takes care of a bunch of this stuff. If you have an invalid signature, you want to stop and not go forward. Don't pass go, don't click $200, do not return any data or functionality. You have a credential, right? Because that's what tokens are. They're time-bound credentials. You have a credential that is not, that's been messed with somehow. And it's at best a bug, and at worst, someone trying to escalate their privileges and attack you. So do not do anything when the signature does not match. But that's not enough. You can't just check the signature. You also need to validate the claims. And remember, the claims are basically the keys of the values that correspond to certain keys in the JSON Web Token. So here we have a payload, and it looks pretty typical. Some of these claims are standardized, and some of these claims are specific to your application. So you can check the standard claims, and I'll kind of walk you through doing that, but you also need to check any custom claims, and that is really business logic that I can't really talk you through. So the ISS claim is who created this token. So that would be, in the scenario we've been talking about, that'd be the OAuth and user management server. We have the expiration claim, which is the time in the future beyond which this token is not valid. So if you look at the EXP claim and it is in the past, you are looking at a stale invalid token and you shouldn't proceed any further. You have an audience claim, which is an identifier for who the token is for. So you can have varying levels of granularity here. This can actually be an array, not just a simple string, but this represents the to-do API. And so the reason you might want to do this, the reason you want to check this is because you can imagine a situation where you have multiple different APIs that are part of your application, and you might be stringing together multiple APIs for different applications. And you might want to authenticate and get back a token that is good for the to-do API, and it marks you as an admin in the to-do API. Well, an admin in the to-do API, if you take that same token and you present it to the accounting API or the money API, well, you probably don't have the same role in that second API. And so if that accounting API is not checking the audience, it's not checking that token was created for it, then you could have escalation privileges. So you want to check that. Finally, you may want to check the roles that are available, but it's important to note that roles are not a standardized claim. Roles are something that FusionAuth uses and provides, other people do too, but this claim could be anything. And as long as the OAuth and user management system knows what claims to put into the token, and the resource server knows what claims to pull out of the token, it doesn't really matter what they're called. It just matters synchronizing those expectations. Again, to reemphasize, validating claims is business logic. Some libraries will help you with some of those standard claims, but looking at roles, for example, would be something that would be on your application to check. So that was all for tokens that have internal structure, JOTs, Paceto tokens, etc. Let's talk about the solution if you don't have internal structure. What can you do at that point if it's a true opaque access token? What you do is what's called introspection, and basically the JOT, again, same situation where the OAuth system has already authenticated the user and the tokens have already been stored on the client in a safe and secure manner. So the client is presenting the tokens to the to-do API, and the to-do API says, hey, I don't know how to handle this token. I'm going to call into this endpoint and say, hey, OAuth system, is this a valid token? And you'll get back a yes or a no. And the yes is, if you get back the yes, then you essentially get back the payload, or something that looks like the payload of that we saw previously. It looks like this. It could be different. It absolutely could be totally different than what you might get from examining the access token if it was a JOT. The important thing, and the only thing that's required in the specification, is this active attribute. And if that will be true if it is a valid token, that will be false, and you won't get anything else back typically if it is an invalid token for whatever reason, right? The signature could be, or it could be, if it's a signed token, the signature could be off. If it's an unsigned token, it could be just it doesn't exist in the database or it's expired. We don't really know. Introspection is a little bit of a black box, but the one thing you want to check is that you have this active claim and it is true. Again, validating claims is business logic. You don't, just because you're using introspection doesn't mean you can ignore the issuer and the expired time and the audience and any other claims that you might want to check. So we're kind of coming to the end here. I really appreciate your time and attention. Let's talk briefly about some alternatives to using OAuth for protecting your API, right? You could use API keys, and API keys could be static, right? Like, so you just create them when somebody signs up and you pass them down to the client and the client stores them. They're not time bound. They don't have any internal structure. Now, I'm not going to argue with you. You could create an API key system that was flexible enough, right? You could create one that actually rotated periodically. You could create one that actually you encoded some structure into it. You could create one that actually supports refreshing them after after a certain period of time. Well, if you do all that, congratulations, you've just reinvented OAuth. So API keys are way simpler to understand from a developer perspective, but they have some significant downsides in terms of security because they tend to be kind of one time they're generated, and then you don't really have any insight or easy availability to rotate them or change them out. You could also use sessions, and this would be where you're just basically tying the user to a cookie-based session or some other kind of session management solution. That's going to tie you to certain kinds of technologies. It's going to force you to route everything through a central session server, or, I mean, you can offload session storage to something like a DynamoDB or MongoDB or Redis, but brings in additional kind of complexity and doesn't let you get that horizontal scalability that you can get if you push a token to a client and then the client can make calls against APIs without going through any intermediary. So, in conclusion, we talked about tokens, we talked about the responsibilities of the client and the responsibilities of the consumer, and that's really all I have. I would like to say thank you all again for your time. If you have any questions, I'm happy to entertain them. If you want to contact me to request, well, actually, I can get the PDF slides to the organizers. That's no problem. But if you have any questions about FusionAuth, there's our website, and you can follow me on Twitter if you'd like.
Well, thank you. Thank you, everyone. That doesn't look like there's any more questions. It's been a quiet night.
Great. Well, then I guess I'll just finish up by saying, hey, thank you very much for having me. And I run a meetup myself, and I know how hard it is to run a meetup. So I'm glad that you all are going strong. And thanks again.